I'm Kevin Pickup from BAE Systems Air, and I'm currently the lead technologist for product verification. So, thank you. So basically, our customer has given us a real challenge over the next epoch of aircraft that we're producing to be 50% quicker with what we manufacture, and also at 50% of the cost. So, as most of you can think, that's a hell of a challenge. Now, the other big thing is we actually don't make many aircraft. We're not like car manufacturers who churn out tens of thousands of items all of the same type. So embracing machine learning to help us in our journey on automation is difficult when we only make roughly 20 to 200 units, or maybe into the thousands in some cases, but not many. And basically, just back a little bit, thanks. Just the key things that we're trying to do here is to assist inspection and augment the experience of the inspector, not necessarily to replace and reap the rewards of pure automation. Okay, so now we can move to the next slide, please. So basically, we want to embrace artificial intelligence and digital transformation technologies. We want to use new materials and manufacturing and smart machines, and we want to use human augmentation technologies again to improve the experience that our inspectors have. Okay, so next slide. So the challenge that we gave was basically to automate inspection of aircraft manufacturing data where low volumes are concerned, performing qualitative checks with go and no-go output. But it's essential that that process is scalable to qualitative checks in visual processes across a whole range of various input data streams. And the particular use case that we gave machine intelligence was digital radiographs on pipe welds, of which we make a lot. And so currently we do manual. It's a very manual process, which doesn't really sit very well with Industry 4 philosophy. And like I said, one of the big challenges is traditional AI solutions only work on large data sets. They're not very governance friendly in that you don't really know what they've done some of the time. And also getting inspectors to accept the machine learning types of things. Okay, so next slide. So again, just to iterate, we want traceability and repeatability in all the inspections that we do, and governance is really, really important. And also it's about confidence, having confidence in the results of the inspection, and you can only get to that through automation. We also want these solutions to be very adaptable to visual inspections, to camera-based inspections, to ultrasound data, X-ray data. So lots of different data types coming the way. And we also want to be very scalable in terms of throwing at different products. Okay, next slide. So the journey so far, well, we've been partnered with a company called Machine Intelligence, somebody we'd never known before, and they're basically an inventor of AI software for visual-based inspection systems. Now, we got through the prototype stage fairly quickly, and it looked really promising. And I'm really thankful that Machine Intelligence was partnered up with us through the MVP stage. And the product that they've developed really is getting better. But, I will say there is still a very, very long way to go before we can put this thing into full production, but we really are looking forward to it. So with that, I really would like to introduce Simon Harding, Director of Machine Intelligence. So Simon, over to you.
So thank you very much for the introduction there. Hopefully you can all see my screen now. So a bit about me. So I'm Simon Harding. I'm the founder of Machine Intelligence. So a little information about the business. There's sort of two main threads to our business. We develop our own AI system, and this is a spin-off from my time in academia, where I worked across computer science, machine learning, computer vision, and unconventional computation. And talk to you a bit more about the AI in a minute. Machine Intelligence also acts as a consultancy, mainly working with SMEs who supply big manufacturers, but also with universities. And there are a set of core needs in this, where there's the need for software, automation, and sort of critically, the understanding of data. And it's a combination of these that sort of brings us here today. So quick overview again of sort of the challenge. So BAE wanted us to develop minimum viable products to assist in their visual inspection processes. And for the MVP, we targeted digital X-rays and of welds in particular. And done manually, this is time consuming, laborious, and a highly skilled job. and it needs to be right 100% of the time, both for safety and cost. They don't want their expensive planes falling out of the sky. And because of these critical issues, BAE wanted the system to work with and not instead of an operator. So other features of the challenge that we encountered as we went on, very limited data set. BAE make relatively few planes per year, and this gives, well, very few bits of photos and things for the training data. Security issues meant they want to do the training of the AI systems locally, not in the cloud. And they also want to know why the AI has done what it has done and have confidence in its ability. So how did we solve the MVP challenge? Well, we did it by combining our AI software with new systems developed for BAE. So we took our machine learning, which is a unique technology based on novel algorithms, and is quite happy to work with a relatively small number of training images. It can work happily with dozens, which is great for this type of problem. It has a very quick setup time. Because you don't need to label too many images, the training can actually be done, set up in a few hours, and the training itself can take minutes to hours, depending on the speed of your computer. And it generates computer programs as an output. And these can be understood by an expert, debugged, modified, extended, whatever you want. And then on top of this AI, we then put some new software to integrate deeply with the BAE inspection process. So what is our technology? So like many other machine learning techniques, this is bio-inspired or biomimetic. However, our technology works in a completely different way to a lot of the techniques you may have seen elsewhere. The name genetic programming gives away quite a bit of what it is and how it works. So the programming bit, we're learning computer programs or synthesizing them automatically. The genetic bit hints that we're borrowing concepts from evolutionary biology. And this working with computer programs brings us many advantages. Like software in general, it's general purpose and application agnostic. It just all depends on what functions you make available to it to use. And here we sit on top of an image processing library, but in principle, you could use any sort of API you've got. We can also add domain knowledge by matching the functions in this function set with what we already know about the task. The system is very scalable, and it's scalable in sort of two ways. One, it can scale with training cases. As I said, it runs quite happily on a desktop, but it will also run in the cloud. The algorithm itself is fully distributable. It's what they call embarrassingly parallel, and it's a very loosely coupled algorithm, ideal for cloud deployment. It also scales at runtime. Maybe the evolved solution benefits from running on a GPU, but the solutions can be tailored to work on an embedded device. So sort of a concrete example. So on the left of the screen there is the DNA, the digital DNA or the genotype. And this can be expressed as a computer program. And the genes encode the function where each of those lines functions gets their input and the parameters. And an evolutionary algorithm manipulates the chromosome through mutation and recombination. And it selects individuals to breed based on their fitness or their ability to solve a particular task. The program may be understandable to a programmer or computer vision expert, but also you get this lovely graphical view. Here it's one image per line of code, which allows anyone to work through the process and understand the logic that the AI is using. So combining this machine learning technique with new software, we made a system that can take a digitally acquired X-ray image, grabbing them automatically from the system after acquisition, process it to be friendly to the human operator, and coincidentally, this actually adds domain knowledge back to the AI that it can use. We can then automatically find defects, label them, size them, classify them. We built tools that allow the user to zoom in and explore to get a real handle on what the AI has come up with. And on top of that is a dashboard, which is used to provide a report which you can drill down into to see where an image is in the processing pipeline, what has been done to it, and the operator can interact here, accept, reject, based on the machine learning guide recommendations. And all this data is captured digitally and stored alongside the image. So where next? Well, any type of visual data can be used, or to be honest, any sort of data can be used given that right function set. So visual images, single channel, grayscale images to hyperspectral, multi-channel ones can be used, ultrasound data, X-rays, perhaps you've got them scanned from film or CT, 3D point cloud data, something else we can manipulate. And any sort of subject matter. The AI does not know if the data comes from wells, metals, plastics, composites, minerals, animals, or vegetables. And given that, we're looking at other inspection processes within BAE. We're also looking at other sort of similar sectors, mostly manufacturing. Anything with NDT or QA requirements sort of is probably a good fit, but also adjacent markets, and food and drink packaging is seeing a huge boom in automation right now. Medical imagery has similar needs. Detecting a lump in a chest X-ray is not fundamentally different as far as the AI is concerned to finding a defect in a pipe weld. So in summary, together with BAE and Digital Catapult, we developed a great minimal viable product for a new visual inspection system. System is easy to use. When running in production mode, the AI runs invisibly in the background, and the operator only has to concern themselves with the reported detections and recommendations. And its novel methodology fits within the goal requirements of BAE. A BAE in inspection general will bring many benefits. By being accurate, it will help reduce waste. Quickly and automatically processing images as they emerge from the X-ray machine means issues can be spotted early, reducing their impact further up the manufacturing process. And this will just help drive up quality. Finally, because the system helps people do things that were previously difficult or possibly impossible, and doesn't require them to have large amounts of knowledge in machine learning, it's empowering. So using our technology, we can help BAE and others make some really intelligent machines. Thank you for your time and attention, and also thank you to everyone at BAE and Digital Catapult for their help over the project.